Hey, welcome back to our last video. This is probably this actually I shouldn't say that. It might not be the last video. I might do another video where I go over exercises, kind of just to see how it's done. If you need it. If you don't need it, then this will be the last video. But I hope you enjoyed this little adventure that we had together on trying to explore the fun facts of, you know, real life examples or real life applications of the linear function y equals mx plus b. And I hope you had fun too. I know this is a pretty boring topic, but I hope throughout this adventure you at least learned something and, you know, became a better person through our philosophy. No, I'm just kidding. Yeah, no, but I hope you learned something, and hopefully these videos were of use. But with that in mind, let's get straight to the video, or let's get straight to the lesson. Like and subscribe. I'm just kidding. Okay, so highlight number 4. Before we get to example 7, the book actually gives us like a little mini lesson on break-even analysis. And I'm going to read the paragraph verbatim, which basically means straight from the book. So, break-even analysis. The goal of every company is to make a profit. A company can make a profit only if the revenue received from its customers exceeds the cost of producing and selling its goods and services. Companies use break-even analysis to analyze the revenue and cost of sales and to determine the amount that revenue can fall while still making a profit. Now, what that means is break-even analysis is basically, it's a tool. It's an analysis that lets company know how much they need to make or how much they need to sell to make up their investment, to make up their cost. If it cost you $100 to make a pizza restaurant, say for example it was a cheap restaurant, you did everything for $100, and you ended up selling 100 pizzas, or $100 worth of pizza. So it cost you $100 to build the pizza and make the restaurant, and then you got revenue, so you ended up making $100. Well, if you made $100 off the pizza you sold, and it cost you $100 to make the chain, how much money did you really make? You have to cover your cost. You can't just build the pizza chain for free. I mean, I wish we could, but you can't just build it for free. So you had to cover your cost. And your cost was $100, and you made $100. So you just covered your cost. You just broke even. And if you don't know, that's a term. I don't know if you've heard the term. Usually here in gambling, you hear someone break even with the dealer. It's usually you don't earn anything, you don't earn anything. The dealer doesn't. It's nothing ventured, nothing gained. So back to the pizza example, you made just enough to cover your cost. You made $0. And the break-even analysis just basically lets us know where that breaking point is. Break-even point, not the breaking point. And I'm pretty sure math makes you get to the breaking point, but we're talking about break-even point. So that's what it means when it says it's on the break-even point. You're making as much as, or that's what it means when it says break even. You made as much as you put in. And it actually helps explain this by referring to a couple of different functions, I guess you can say, or formulas, functions. Now, I actually made a little side note right here. Anything higher than the break-even point and you make profit. Anything lower than the break-even point and you lose profit. Think about it like the equilibrium point that we learned in the supply and demand video. And if you don't know the equilibrium point, you're still iffy, then, pause the video, go back and review that, and then come back. So it's the same thing. It's when supply equals demand. When you're supplying just as much as people want, you're selling your goods just as much as people want. So it's good, you're selling everything. It's kind of the same thing, you're making as much money as you put in. So I hope that makes sense. And just how in equilibrium point, if you go higher, you're in a surplus. If you go lower, you're in a shortage. Well, I mean, it's the same kind of similar. If you're higher than the break-even point, you make a profit. If you're lower, you, don't make a profit, you lose money. And if you're at the break-even point, then you made as much as you put in, so you don't make anything. Zero profit, $0. I hope that makes sense. And it says right here. Yeah, actually put it right here. Anything lower, you lose profit. Now, the book gives us a couple of formulas to basically kind of explain what it means when it says like revenue, break even is revenue minus cost. When revenue equals cost, and like how they got to that conclusion. So let's do that. Let's dissect that little tiny break-even analysis explanation. So it says right here, let P be the price per unit and let X be the number of units sold. Price per unit, that's slope. I hope the last video, you're starting to think like red flags. And I'm gonna I'm gonna kind of breeze through this video. And kind of just, instead of trying to explain all of it, I'm just gonna point out like red flags so you can see in real time. Not red flags. I should stop saying red flags. This isn't a bad, breaking point red flags. It's a bad relationship. Like alerts, little alarms. So let's read this. Let P be the price per unit. Alarm, price per unit. I hope you know what that means. We've been repeating that. And let X be the number of units sold. Demand. Okay, well, that's fine. We don't really know what that means, but we know the price per unit. We kind of know like, okay, that's going to be a slope. So the revenue, R of X, is the amount of money that a company receives. R of X. R of X, that should look familiar to you. That should look like F of X. And we should, F of X is equal to Y, so R of X is equal to Y. It's the same thing. So R of X is the amount of money that a company receives. It is the product of the price per unit and the number of units sold X. So let's think about that. It is the product, where is it? It is the product of the price per unit. Price per unit, that's slope, P. And the number of units sold, product. Product is, when you think product, you should think multiply. It's another language terminology. Product, multiply. The product of the price per unit. So in this case, your price per unit, they told you, was P. And the number of units sold, which is X. So they're telling you, it is the product of the price per unit, P, and the number of units sold, X. So product means multiply. So they're basically telling you, it's the price per unit, P, multiplied by the units sold, X. So R of X is equal to P times X. I hope that makes sense. Like I said, it's more of just like reading, like language-wise, but that's kind of how it is. R of X, that should automatically alarm. R of X looks like F of X, so that's kind of going to be on the left side of the equal sign. Just how Y is always on the left side of the equal sign. Sometimes when we're dealing with Y equals mx plus b, Y is always on the left side of the equal sign. And then it's telling us the product of the price per unit and the number of units. So the product, okay, so multiplying. What are we multiplying? the price per unit, that's P, it tells us that's P, and the number of units sold, and it tells us that's X. Okay, so you're multiplying P and X. Hope that makes sense. And I made a little example right here. You know, the price per item, let's say it's $2. So let's say price per unit is $2. Price per unit for pizza is $2. And then the number of units sold is 100 pizzas. So, each pizza slice costs $2. That's your price per unit. Each slice of pizza is $2. And you sell 100 pizzas. So, I hope that's a little, clicking a little more revenue, so 2 times 100 is $200. You made a revenue of $200. You sold 100 slices of pizza, and each slice of pizza is $2. So at the end of the day, when you're counting your money, you made $200. And the book just tries to confuse you with all of these weird languages, but hopefully the more you practice, the more you start recognizing these like keywords, the product of, price per unit, number of units sold, X. Let's move on. The next thing to talk about is profit. And this one's a little more easier. The revenue was a little harder to explain. Profit's a lot more easier to explain. The book says profit is the money a company makes after paying its cost. It's the difference, the other key word, difference, you should think subtracting. It's the difference between revenue, R of X, and cost, C of X. So profit is basically revenue minus cost. And it makes sense, you want to start a pizza business that costs, $200, and you make a revenue of $200. Well, you have to, it's not free. You can't just make a pizza store for free. You're gonna have to pay people to probably change out the store. You're gonna have to pay people to install the pizza equipment. You're gonna have to pay people to actually make the pizzas, and all of that ends up costing you, ends up costing you. So let's say, for example, that all cost you, for some reason it's super cheap. It costs $200 to make a pizza store, and then your first day you made $200. Or you broke even, and that's basically profits. Revenue minus cost. We've been kind of doing this our entire life. How much money did you make? Oh, I made $600. Oh, nice. But how much money did it cost to, for example, I'm making strawberries, chocolate strawberries, How much money did you make from selling chocolate strawberries? Oh, I made $100. Oh, okay. Well, that's your revenue. That's how much money you made in the day. But your profit is your revenue minus your cost. You still got to cover your cost. So let's say it cost you $50 to make the strawberries. Okay, so, 50. Oh, actually, I have an example. Okay, nice. I have an example. Cost $100 for pizza ingredient. Okay, so it cost $100. Let's do the strawberries. It cost $100 to make the chocolate strawberries. That's how much money it took for ingredients. So that's your cost. That's your C of X. And you made $200 from selling your chocolate strawberries. So you can't really say, oh, I made a profit of $200, because you still have to cover you made $200, you sold $200, but you still have to cover your cost. Those ingredients had to come from somewhere. So your profit would be your revenue minus your cost. Your profit would be $100. You made $100 that day. Good job. So break even is when profit equals 0. We've been kind of hammering that into you. So we can say that, we kind of just explained in the above that if this is bigger, if R of X is bigger, if your revenue is bigger than your cost, you make a profit. If your cost is bigger, then you don't make a profit. This is a negative number. You lose money. So that's kind of funny, If this one's bigger, you make profit. If this one's bigger, you lose profit. What if they stay the same? What if this is exactly the same as this? When revenue is equal to cost. That is the break-even point. When profit equals zero. And we kind of proved, this is basically just a giant proof. Revenue is how much you sold. It's how much your item cost, and then how many times how much you sold of that item. Each pizza slice cost $2, and you sold 100 pizza slices. You made $200 that day. Profit is when you get your revenue and you subtract your cost. Obviously nothing's free. There's no such thing as a free lunch. So you get your money you made that day, $200, and it cost you $100 to buy the ingredients for your pizzas. So you made a profit of $100. Kind of tells us that. And it basically says, okay, well, we said that if your revenue is bigger, you make money. If your cost is bigger, you lose money. So what if they're equal? You don't earn anything. You break even. So there's a lot of hammering, but I hope that still helped out a little bit. So now that we know that the break-even point is where zero loss or profits, when profit is zero, let's get down to actually tackling the example, the last example. A firm produces, example number 7, a firm producing poultry feed finds that a total cost, C of X in dollars, of producing and selling X units is given by, and then it gives you the equation. C of X is equal to 20X plus 100. I hope that looks familiar to you. Y equals mx plus b. You know what your slope is in that formula. You know what your y-intercept when x equals 0 is in that formula. Or your constant, you know which one is your constant in that formula. So if I told you, what's your rate of change? Boom. You automatically know. Rate of change is slope. What's your constant? Boom. What's your y-intercept when x equals 0? Boom. All right. The management plans to charge $24 per unit. Okay, per unit. All right then, per unit. I hope that raises some alarms. That's another key language that we learned. Management plans to charge $24 per unit for the field. Determine the revenue function. Okay, well, it's asking us for the revenue function. We learned the revenue function. Remember how in the previous explanation we said that revenue is the product of the prices per unit and the number of units sold. So it's basically, price per unit, P, times the number of units sold, X. It's P of X, P times X. We solved that. So now that we know which tool we're working with, because remember, we have to choose our machines. We have to choose our machines carefully to have it pump out the value that we want it to pump out. So now that we have the machine we're working with, R of X equals P times X. And they tell us price per unit. Because remember, price per unit is P. They told us that. They told us price per unit is $24. So that should be an alarm. Price per unit. Okay, we know price per unit is P. They're going to give us a value for P, and it's $24. 24. Do we know X? So for example, sorry, I got a little pause. I'm trying to switch the video. I'm trying to switch the example to the other example. Yeah, there we go. It's telling us, so that's basically all it's saying. It wants a revenue function. It wants us to come up with an equation, just how in example 5, we had to come up with our own y equals mx plus b. We have to come up with our own revenue function with, remember how in the example 5, we had to come up with the y equals mx plus b with the value they give us. Same thing, we have to find the revenue function r equals p times x, with the value they give us, which is p equals 24. So once you plug that in, you get r of x equals to 24x, because you already know your revenue function is p times x, price per unit times units sold. They gave you price per unit, so you can just, that's p. You can just plug it in. Do we need to know x? I put a little side note. Do we know x? Do we care? Is the question telling us to find x? Because the question is basically saying, what's the revenue function? What's the linear function for this case? That's all it's asking. It's just asking for the function. It's not asking to figure out how many units are sold with this cost and this price per unit. No, it's not asking. It's just asking for what's the function. And we found the function. R of x equals 24x. Now remember this one, because this is going to actually pop up. This is actually going to be used in the next example, which is example B. So let's go to example B. Pull that up. How many units must be sold for the French picker? There you go. Example B. How many units must be sold to break even? Okay, so that's the question. Remember the key terms, the alarms. How many units must be sold? Well, what's a unit? Well, we know units sold is X. We actually have it right here. We know that units sold is X. How many units must be sold to break even? So basically now it's telling us to find X, because it's asking us how many units must be sold. Okay, well, we know units sold is the variable that equals units sold is X. So we need to find X. The next question you should be asking yourself is break even. What's break even? You know that break even is when profit is 0. Well, what's profit when it's 0? I hope you should start, these alarms and these, kind of domino effect. The break even is when profit equals 0. It's when cost equals revenue, when you made just as much as you put in. So that's the domino effect, How many units must be sold? Okay, that's what they're asking for X, because they're asking for the units that must be sold. And we know that the units sold equals X. And it's also how many units must be sold to break even. So we know that break even is when we don't make a profit, when profit equals 0. And we know that when profit equals 0, it's because revenue must equal cost. You're making as much money as you're putting in. So we need to know that cost is equal to revenue. C of X is equal to R of X. Now, this is where you start playing around and pay attention. They gave us C of X. They gave us, in the beginning of the example, they gave us C of X, which was equal to 20X plus 100. And we found R of X, the function R of X, which is 24 times X. I have an alert, and it's basically what I said. Break even is like the equilibrium. It's similar. So break even is similar to the equilibrium concept, slightly different name. That's just basically it. Just similar concept, just slightly different name. So we know that break even is when cost equals revenue. And they gave us a cost function. And they gave us a revenue function. And just how in the supply and demand, when they asked for the equilibrium, when supply equals demand, we knew that we can just set the demand function equal to supply function. It's the same case here. We can just set the revenue function, which is 24x, equal to the cost function, which they gave us, 20x plus 100. And at that point, it's just simple kind of basic algebra or basic mathematics. You subtract 20 from both sides. You have 4x equal 100. You divide x. Well, you divide by 4, sorry. You divide by 4. X equals 25. 100 divided by 4 is 25. So that's what I mean when I say, you kind of have to recognize the language. Units must be sold, X. Break even, we know what that means. Profit equals 0. Well, we know what profit equals 0. Revenue equals cost. Revenue equals cost. Well, they gave us two functions of revenue equals cost, so we must set them equal to each other. You want the break even. They gave us two functions. They said cost is equal to revenue. Well, let's set them equal to each other. That type of domino language type of thing, Oh, I recognize these words. I can start using them. All right. Now, let's see if I have the last example. Where's my last example? Where's my last example? Is it this? Yep, here it is. C. What is the profit if 100 units of feed are sold? Again, just language. Again, plugging in info we know. There we go. What is the profit? Read that again. What is the profit if 100 units of feed are sold? Well, 100 units, we kind of know, 100 units that are sold, that's X. So it's giving us a value. Units that are sold, it says that it sells 100 units. So we know X equals 100. And it's asking for the profit. Well, what's the profit? Think back to the language. Well, okay, we learned profit. Profit means the same thing as revenue minus cost. Profit equals revenue minus cost. So let's think back to the question we did before, the B, where they gave us a revenue cost function and they gave us a revenue function and then they gave us a cost function, and we were supposed to set them equal to. They wanted the break-even point, which we know is when revenue equals cost. So we set them equal to each other. That's kind of their identity. R of X in this example is 24x. Our revenue function is 24x. Our cost function is 20x plus 100. So when they ask for the profit, we should automatically start thinking, well, profit is the same thing as revenue minus cost. Well, we have a revenue function and we have a cost function. Why not just, plug in the information that we know to the formula? P of X is revenue minus cost. Well, revenue is 24x. The function of cost is 20x plus 100. It means the same thing. We're just replacing it with values that we already know. So once you do, and at that point it's basic, like it's the same thing. It's basic mathematics. 24x minus 20x equals 4x plus 100. It's minus 100 only because they put parentheses around this. So you have to distribute this negative sign because you're not really subtracting by 20x, you're subtracting by the function. So like this thing is this whole thing, if that makes sense. That's why it's a negative, because you distribute it. And it still makes sense. I mean, think about it, you distribute it, that becomes negative 20x, that becomes negative 100 or minus 100. This becomes a positive. Well, what's 24x plus negative 20x? Well, that's 4x. And then you have the minus 100, 4x minus 100. That's where the minus 100 comes from. But I hope you know that one. So once we have our machine, we just created our machine again. Boom, we mixed two machines together to create one ultimate machine, the profit machine. And this profit machine is gonna let us know how much money we're gonna make if we sell 100 units. So we know that X equals 100. Boop. We just plug it in. And once we plug it in, that profit or that machine is gonna pump out a value for a profit. So let's just do it. I mean, I really think I need to do it, but I'll like do it like, I'm not gonna write it down. I'll just do it like quickly. So like, it's X equals 100. So 4 times 100 is 400. And then the cost ended up being 100. So, 400 minus 100, profit is 300. You made $300. Once you subtracted out your cost, you made $300 that day. That is your profit. Also called net profit. If you ever hear someone say net worth, it's all the stuff all the money they have minus all the costs that they need to have, like bills and stuff. That's net worth. Net profit. Profit's the same thing, revenue minus cost. Alrighty, so the last example, how many units must be sold to produce a profit of $900? So same thing. We have the profit equation. They gave it to us. P of X is equal to 4 of X minus, actually, we solved this. We solved for the profit formula. 4 of X minus 100. So all we need to do is figure out what they're telling us and what we need to find out. How many units must be sold to produce? How many units must be sold? Okay, that's a red flag. Red flag. That's an alarm. What's X? Units that must be sold is X. How many? So what's X? To produce $900 in profit. Okay, so they told us profit is $900. How many units do we need to sell to get to this profit? So we know profit. They told us. And they told us we need to find out X. Well, this machine, like I said, and like I've been repeating, this machine basically lets us, plug in values that we know and pumps out values that we don't know. We know P equals 900. And we don't know what X is. So we plug in 900 and we let the machine do the work. Well, we have to do the work. The machine is lazy. So we have to do the work. So, you just basic math times 100 times 100. Cross this out. And then you divide by 4. Divide by 4. X equals 250. So you need to sell. Did we answer the question? How many units must be sold to produce $900? 250. That's how much needs to be sold. 250 units. So did we answer the question? How many units must be sold? Yeah, asking for how many units must be sold. Yeah, we did answer the question. It's 250. Are we done? Yeah, we're done. That's all they asked for. It's like minimum wage work. You don't do more than they ask. You do the minimum they ask, and then you're done. They wanted X, we found X. Alrighty, so I hope these videos have been helpful. I'm sorry if they're pretty long. I'm just trying to hammer down a lot of these points. There's a lot of repetition repetition itself adds 10 minutes. And then my very dry humor jokes add another 10 minutes. So, that's unfortunate. I don't get paid to do stand-up comedy, as you can tell. But I hope you enjoyed these videos. I really did, and I hope this journey has helped in some way. And if you have any questions or anything at all, let me know, and I'll get back to you. Alrighty, peace.